This video walkthrough is going to show you how to do the calculations and data analysis for the Kinetics lab. You'll also probably find that spreadsheets and the ability to use them for this type of analysis is going to be useful to you in the future. So you should already have the concentration of the standards that you prepared in class versus absorbance graphed. If you haven't put in a trend line yet, you should, and your graph should certainly have a title and both axes should be labeled. I chose to put the data points here. It's not necessary since you should have a clear data table in your laboratory notebook, but I think it looks good. It shouldn't have this line connecting the dots. That is not very scientific at all, but I can't seem to get it to go away. So under the chart editor, which you double click on your image to get to, and under the customize section, you will see that under the series tab, I don't know where that dictionary came from. Under the series tab, you have the option to add a trend line, and that trend line can be shown on the graph if you click use equation as your label and then click show R squared value, and it'll give you a value right here that tells you how closely your data points fit the line that this is the equation of. So an R value of 0.995 is not as good as it could be, and you may notice that this data point right here for 25 micromolar crystal violet is lower than what we would expect for linear. Looks like this is going in a nice straight line and it should go right up like that, but no, that data point is low, which is something we expected at such a high concentration value. We don't usually get good numbers from the spectrophotometer up in this range. Since we are only planning on testing our crystal violet at 12.5 micromolar and lower, I'm actually going to delete that data point because I can see that it's not linear at that range, and I know that this range from 0 to 12.5 micromolar is plenty, and that's right where we're working. Notice how that gives me an R value of 1. So the equation of this line is 0.0748x plus 0.00162. So that's right here. We want to turn absorbance values into concentration values. So concentration is X on our graph. So that's why I took the equation of the line right here that the spreadsheet made, and I solved it for X. What I'm going to do with this equation is if I put in the absorbance that the spectrophotometer is going to give us, it will turn it into X. So what I'm going to do now is enter in an absorbance value right here. I'm going to enter in absorbance of 1.1, something we would expect for like 13 micromolar or something just above 2.5. And in this cell right here, I'm going to insert this equation by pressing the equal sign. That is going to open up this function dialog here where I'm actually writing an equation, but I'm doing it in Excel way. So up here I can type, and I'm going to put in a parentheses, and instead of typing in the variable y, I'm going to click on this box D2, pachang, and then D2 shows up right there. Then I'm going to continue with my equation. Y, D2 is y, and then 0.00162, and then close my parentheses, and that gets divided by 0.0748. Does that look the same? Okay, so y is D2. Yes, and so when I press enter, notice that when you click on this cell, the equation is there. What it's doing is it's plugging in value of D2 for the D2 right here. So it's pretty much whatever I put in this cell is going to be Y, and whatever I put in the, and then what's going to happen in this cell is my concentration is going to pop out. I'm having this computer do the math for me. So what's even more powerful is the ability to just copy this, Command C, and then click on the next cell, Command V, Command V, Command V, Command V, Command V. So what this has done now is put in the exact same equation, but it has changed it to D3. It's so smart, it knows it's on the next row. So whatever I put in this cell is going to give me concentration in this cell right here. So if I put in 1, and then 0.8, and then 0.54, if these were the absorbances that my spectrophotometer gave me, then right here, voila, I have the machine doing the calculations for me and turning it into concentration. So let's go on down here. What you're going to want to do is put in all of your absorbance values. You're going to have like 40 or 50 of them, and then fill down to get all of the concentration values. And then it might look something like this. You will also need to fill in all the time values. So now that I have all of my concentration values calculated by the spreadsheet, I'm going to graph concentration versus time. I can click on the Insert Chart feature, and it thinks it knows what I want, but of course it doesn't. It just made some random chart there. I'm going to select Scatter Plot, and the data range that I'm looking for is concentration. So I'm going to go C24. If you press the Shift key, it'll select the entire range. You can also drag to do it or type it in. So I still need to set my x-axis. I don't know what it's using right now as an x-axis, probably just the numbers right here, but who knows. I'm going to add the x-axis, and that is going to be 40 seconds down to 900. Okay. Well, there's my lovely graph. And so that's all this screen is for, is to figure out what you're graphing versus what. So I'm going to go customize this graph now with some titles. The chart title is going to be concentration of crystal violet versus time. My horizontal axis title is going to be time in seconds. My vertical axis tile is going to be concentration, and that is in micromolar. So that's going to give me all of my units that are required, my labels for both axes and for the entire graph. And so those are a requirement for any graph that you put into a laboratory notebook. I'm going to go to series, and I'm going to apply a trend line, and I am going to, I don't care about the equation because I'm not going to use it. I do want to look at the R value, and what it says is that 0.985, this really isn't a line. This is the best fit line right there, and it doesn't really fit my data. So this isn't a zero order reaction. We're going to have to plot the other two values versus time to see how this goes. Okay, so let me show you how to do that. I'm not going to show you how to plot them, but I'm going to show you how to get the data, and then you would plot them just like I showed you for concentration versus time. So in this cell, I will again press equals, which gets me into the equation editor, and I can type in ln, which is the code for the function for natural log. Then you'll have to put in a parenthesis, and after that, you'll be able to click on the cell that you would like to have the natural log of, which is this one right here with the concentration of crystal violet in it. And then I'll have to close the parentheses and press enter. And this is the natural log of what's in C24. Now I'm going to copy that and paste it in all of these cells. And so notice how this has got the natural log of what's in C65. So wow, that did a lot of work for me. And then you're going to want to go ahead and do exactly what I showed you before and graph natural log of concentration versus time. And get a graph just like this. Maybe that one will be linear. I don't know. We'll see. So this equation is going to be equals 1 divided by that cell right there. There we go. I have the format set up, the number format set up right now. I already changed it before when I was doing this to number. The automatic is to have all these decimal points in there. So the reason why I don't have so many decimal points is because I changed it to number. But you actually need more decimal places than that. So I'll show you how to do that. Probably shouldn't have messed with it, but custom number format. And then I pick this one, but I add another 0 to it and I say apply. So this also tells you the reciprocal, and we can copy that and paste it all the way down. And then you would also graph this versus time. One of those three graphs is going to be a straight line. You don't have to put this into your laboratory notebook, so it doesn't really matter what this looks like. I just like it to look pretty. You will include your three graphs into your laboratory notebook. Actually, maybe you should put that in there. It sure is nice, and it'd be easy to print. But that's up to you guys. Chat with you later.